Okay, we'll carry on here. Somebody just remind me when we got about 20 minutes left in class to pass around this attendance form. So we'll do it just as before. We'll pass it around. You sign in, or just print your name, and if your name's on the attendance sheet, you'll get credit for attendance today. Okay, and we'll do that at the end of class. So I'll try to remember, but if I don't, somebody point that out to me. Okay, so all of this stuff with, using the normal table becomes handy if we combine this with what we learned back in chapter 3. Okay, so just a few chapters ago, so that this is chapter 3. I don't know if you guys remember this, but does anyone remember, what is a z-score? The definition of a z-score. Okay, so this was back from chapter 3. Do you guys remember this? Yeah, what's a z-score?
Tells us how extreme a point is.
Okay, that's one of the purposes of a z-score.
Or distance from the mean measured in standard deviation.
Yes, the z-score is the distance from the mean measured in standard deviations. Okay, and so the way we calculate z is we take our x and we subtract off the mean, and we take that distance and we divide by the standard deviation. Okay, in chapter 3, the symbols that we used were z is equal to x minus x bar divided by s. Okay, in chapter 6, we are talking about the mean of a population, so the symbol we use for that is this. This is the symbol mu. Okay, it's the Greek letter for m. Okay, and the standard deviation of the population is this symbol, which is called sigma. Okay, so in our case, the z-score is going to be x minus the mean mu divided by sigma. Okay, and so we can then, if we turn our measurements into z-scores, we can then use our z-score to look that number up in the standard normal table. So before we were just saying, what is, what's the area, or what percentage is below z equal to 1.5? We can now take measurements such as a person's height and then say what percentage of males in the United States are shorter than 6 feet tall. What percentage of, I don't know, cows weigh more than 1,000 pounds or something like that, okay? So we're no longer dealing, we're taking measurements now, and then we can use our normal table by turning them into z-scores, okay? And so this is how it becomes useful, okay? So we can say something like the heights of adult males in the U.S. are normally distributed. Okay, so it's important that we say they are normally distributed, otherwise all of this doesn't work, okay? So, the use of the standard normal table only works if the data is normally distributed. So it's very important that somewhere in the problem it says these measurements, such as the heights of males in the United States are normally distributed. Okay, and we will say the mean height is 69.5 inches. And we will say the standard deviation of heights is 3 inches. Okay? So I'm going to break this problem out into a few things. Okay? So the overall problem will be what percentage of males in the US are over 6 feet tall. Okay? So first we're going to have to say, you know, part A will be what is the z-score that corresponds to 6 feet. Okay. So I guess I should say 6 feet would be 72 inches. Okay, so what is the z-score that corresponds to 72 inches? Okay, and then part B to answer this question is what percent is over that z-score. Okay. Now on the test and even in the practice problems presented in the quiz or in this week's practice problems, it's just going to be in this form. Okay. What percentage of males in the U.S. are over 6 feet tall? It's your job to then recognize, hey, there's two parts to this. First, I got to find the z-score. Then I've got to look up that z-score and answer what's the percentage that's over that z-score. Okay. Okay. Can we get this z-score here? How do we get the z-score? What do I do? All right. So what is my x? I'm going to do x minus mu over sigma. What's my x? X is 72. What is mu? 69.5. And I'm dividing by sigma. What's my sigma? 3, right? Okay, so it's all presented in the problem. The mean height is 69.5. So, you know, 69.5 is mu. The standard deviation of heights is 3. This is my sigma. Okay, so I do 72 minus 69.5 divided by 3, and I get 0.833333. Okay, now what I'm going to do is I'm going to look up this z-score in our z-table, in our standard normal table. Now our standard normal table only allows us to look up z-scores up to 2 decimal places, okay? So this means I have to round my z to 2 decimals. Round z to 2 decimals. Okay, so that gives me z equal to 0.83. Okay, and then we look up z in the table. Okay, the table always gives me the area to the left. So what is the area to the left according to the table? Yeah, so I look up 0.83 and I get 0.7967. Are you guys still with me here? Okay, so my picture, if I were to draw a picture, I have 69.5 in the center because that's my mean now, and I'm drawing a line at 72, and I want to know how much, what percentage of males in the US are over 6 feet tall. This is what the answer that I want. Okay, so is my answer 0.7967? No, what do I have to do to get my answer? I have to subtract that from 1, right? Because 0.7967 is the area to the left, but the area that I want is over here, okay? So the area to the right is equal to 1 minus 0.7967. And I get 0.2033. Okay? So the question, what percentage of males in the US are over 6 feet tall? That answer, 20.33%. Okay, I'll let you guys write that down, and I'll give you guys another problem like this to practice. I guess I should just make sure everybody's okay with this first.
I'm not.
You're not? Okay, that's good. Where are you running into some problems?
Where did you get 0.79? Well, I got it, but how did you know to subtract that?
Okay, so the question, let's look at this question here. I'm going to draw a box around it. It says, what percentage of males in the US are, and the key word that I'm looking at, over 6 feet tall? Okay, so over, I want basically 72 inches and taller than 72 inches. Okay, so what I want is not the area, I don't want 72 and below, I want 72 and over. So I want this side over here. Okay, so I want the area to the right. Is that okay? All right. Well, I know whenever I look up a number in the table, okay, this case I looked up z is equal to 0.83. If I look that up in the table's always going to give me the area to the left. Okay, but I don't want the area to the left. I want the area to the right. Okay, so I know that the area to the left is 0.7967. I know everything adds up to 1. So in order to get this part over here, I'm going to say 1 minus this part is going to be this area here. So that's how I get 0.2033. Okay. All right, do we have this all written down? Those of us taking notes? Okay, let's try another one of these types of problems, okay? So this time I'm going to say, I don't know, for a certain species of turtle, we will say the weight follows a normal distribution. Okay, the mean weight is 450 grams. The standard deviation is 80 grams. Okay, so I'm going to ask two questions here, or we'll do we'll do two questions. What percentage of turtles weigh less than 400 grams? And B will be, what percentage of turtles weigh more than 360 grams? Well, hang on. Okay, I'll say more than 301 grams. Is that right? Oh, I don't know what I did. Okay. Okay, we'll just do that. What percentage of turtles weigh more than 301 grams? What percentage of turtles weigh less than 400 grams? Okay, go ahead and take a few minutes to work these out. All right, let's take a look. I know a lot of you guys are still working, but let's take a look here. Okay, now problem A says what percentage of turtles weigh less than 400 grams? So I always find it helpful to just draw a little picture of what it is that I wanted, what I'm looking for, right? So here I've got the hill, okay? The mean weight is 450, so I'm going to put 450 right here in the middle, okay? And then it says what percentage of turtles weigh less than 400? Now 400 is smaller than 450, so I know I'm over here. And it says what percentage of turtles weigh less, so I want the area to the left, okay? I don't want the area to the right this time. Okay, so the first step 1 is to find our z, right? Find the z that corresponds to 400. So z is going to be 400, it's x minus mu, 400 minus 450, divided by the sigma, our standard deviation of 80, okay? And when I do this, I get negative 0.625, okay? And I think a lot of you guys got this far, okay? And it's very important that you keep the negative sign there, okay? It's always, z is always x minus mu over sigma, okay? Some people did 450 minus 400. That's going to give you the wrong answer. Don't do that, okay? You know, if it's helpful, say, you know, as you're going through the problem, say, hey, this number is mu, okay? And that way, you know, and you'll say, hey, this number is sigma, okay? All right, so we got z is equal to negative 0.625, and that's great, but that's not our answer. We have to round to 2 decimal places to use our table. Okay, and so when we do that, we get z is equal to negative 0.63. And now we go to our table, and we're going to look up z is equal to negative 0.63. So I'm going to go to the row negative 0.6, and I go to the column 0.03. So 1, 2, 3, I get 0.2643. That's the column. Okay, so the area to the left is 0.2643. So that is this part right here, 0.2643. Is that the area that I want, or do I have to subtract this from 1? This is the area that I want, okay? What percentage of turtles weigh less than 400 grams? I don't need to worry about the area to the right. I want the area to the left, okay? So I just turn this into a percentage, and I say 26.43%. And there you go. Yes, a question?
I forgot to round it to 0.63. I just used 0.62 on the exam.
So your answer will be close but off, okay? Now on the exam next week, it's multiple choice, all right? So you might get away with it and say, oh, I looked up, you know, the wrong number, but my answer is really close to this one, okay? And then you'd probably choose that. But, you know, it's, you know, rounding, you know, that's a skill you should have learned a while ago, and it's an important one, okay? So, you know, round properly. All right, let's do this next one, okay? What percentage of turtles weigh more than 301 grams? Okay, so if I draw a little diagram, okay, again, I'm putting 450 in the middle, 301 is over here, and I want the area this time to the right, okay, because it says more than 301. So here I'm going to say z is equal to 301 minus the mean of 450 divided by our standard deviation of 80. 301 minus 450 divided by 80 gives me negative 1.8625. Okay, and so here, again, I always have to round to 2 decimal places. And so that leads me to z is equal to negative 1.86. We look up z equal to negative 1.86 in the table, and we get the area to the left of negative 1.86 is 0.0314, right? Negative 0.86 when z is equal to negative 1.86, I have 0.0314. Okay? Is that the answer that I want? No, this time I want the area to the right. So I'm going to do what? I'm going to do area to the right is equal to 1 minus 0.0314. So I do 1 minus 0.0314, and I get 0.9686. Okay, and so my answer here, 96.86%. Okay. Okay, on the test next week, one of the answer choices will be 0.9686. One of the other answer choices will be 0.0314. Okay, you've got to know, am I asking for the area to the left or am I asking for the area to the right? And you got to pay attention and say, you got to look for keywords like, is it less than 400 or am I asking for the more? Okay, these are the key differences, whether you want the area to the left or to the right. Yes?
Is it always going to be 1 minus that if it's more? Or
Yes. Yeah, if it's asking for something or more than something, it's going to be the area to the right. So you're going to take 1 minus the area to the left. The table will always give you the area to the left. Okay? Now, I'm just going to say this quickly because some of you guys might have picked up on this. But if you haven't, and what I say right now is confusing, don't worry about it, okay? But if you've picked up on this pattern, you can use it to your advantage as a shortcut, but again, you know, sometimes if you use the shortcut wrong, you're just in trouble. But the table is symmetric, so the area to the left of -1 is the same as the area to the right of +1, okay? And so if a question says, you know, what percentage of turtles weigh more than 301 grams, and we had to do 1 minus the area to the left, another option is to have just looked up z equal to positive 1.86, okay? But I just said that out loud, and if that made sense to you, great. And if whatever I said just sounded like blah, 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 don't worry about it, okay? That's... Okay, we have a few more of these types of problems dealing with the normal model, okay? So we'll still say turtle weights. I don't know why we're dealing with turtle weights today, but we'll say turtle weights follow. So this is kind of a shorthand for saying turtle weights follow the normal distribution with mean 450 and standard deviation of 80. This is a shorthand way. So on the previous slide, I wrote it all out. I said turtle weights follow the normal distribution. The mean is 450, and the standard deviation is 80. I can also just write it this way: turtle weight squiggle n 450, 80, and this means exactly the same thing that I wrote out on the previous page. Okay, so this can save a little bit of time in writing things. Okay. And now we can say things like, I can ask another question, okay? I could say, what is the weight that corresponds with the 90th percentile of weights. Okay? What does it mean to be in the 90th percentile? Okay, that means 90% of people have scores or weights or whatever lower than you, and essentially only 10% are above you, right? So if I were to draw this picture, okay, this means that 450 goes in the middle, and here I'm drawing a line, and basically the area over here is going to be what? 90%, and the area above here is 10%, okay? So what this says is that, oh, we can find the z that gives me an area to the left of 0.9, okay? So the steps here, so what is the weight that corresponds to the 90th percentile of weights, okay? There's two steps, okay? Step 1, find the z that corresponds to 90% to an area of 90%. And then step 2 is turn the z-score into a measurement, or in this case, a weight. Okay, so what is the z that corresponds to an area of 0.9? Did you guys get that? Z is equal to 1.28. All right, do you guys see that? We go to the z table, we're finding the number that's closest to 90%. That number is 0.8997, okay? This is the number I have that's closest to 90%. 0.9015 is close, but not as close as 0.8997. This is as close as I can get to 90% in the table. That is z equal to 1.28. Do we see that? So I'm in the row 1.2, the column 0.08. Z equal to 1.28 gives me 0.8997, which is about as close as I can get to 90%. Okay, so step 1 is find the z that corresponds to an area of 0.9. That z is 1.28. Okay, how do I go from a z-score back to the measurement? Okay, well, if we think about what a z-score is, it's the distance from the mean expressed in standard deviations. So that means my measurement is 1.28 standard deviations above the mean, okay? So, or the weight of the, the measurement corresponding to 90th percentile is 1.28 standard deviations above the mean. Okay, this is from the definition of a z-score, right? So the measurement corresponding to the 90th percentile has a z of 1.28. What that means is that the measurement corresponding to the 90th percentile is 1.28 standard deviations above the mean. Okay? So how do we solve for what x is? Well, we can use this formula. We can say z is equal to x minus mu divided by sigma. I'm going to plug in all of the numbers that I have. I know z is 1.28. I don't know what x is. That's the number I'm looking for. But I know that the mean is 450, and I know that our standard deviation is 80. Okay? This is just plain old algebra. Solve for x. What do? I multiply both sides by 80. Here I'm going to write in a different color here. So I do times 80 times 80. Okay, so now I got 80 times 1.28 is equal to x minus 450. And so I add 450 to both sides, and I get 450 plus 80 times 1.28 is equal to x. And look at that. This is, my mean is 450. Each standard deviation is 80. I want to go 1.28 standard deviations above the mean. That's exactly what I've written out here. My x is 1.28 standard deviations above the mean. So here my x, I just got to plug this in, 450 plus 80 times 1.28, 552.4, 552.4 grams. What is the weight that corresponds to the 90th percentile? 552.4 grams. And there's your answer. Okay. I would like to be able to give you more example problems like this, but we're going to run out of time if I do that, okay? So there are, in the practice problems this week, you have a couple problems like this. So please make sure you can do this type of problem as well. You'll definitely see them on the midterm exam, okay? Are there any questions on this before I go on? Because this is the only kind of example of this type of problem that you'll get to see today. Yes, question?
Could you possibly just run through step 2 again?
Yes, absolutely. So in step 1, we found our z-score, okay? Our z-score is 1.28. What we want to do in step 2 is, because the answer to this question isn't, what is the weight that corresponds to the 90th percentile, right? We want to know the weight of the turtle. We don't want to know z is 1.28. That's not helpful to us. We want to go from z is 1.28 to say, hey, that turtle weighs 552 grams, okay? In order to do that, we've got to turn our z into a measurement. That's what step 2 is all about, okay? So effectively, what I'm doing is I'm taking my definition of a z-score. Okay, this is the formula for z, which is z is equal to x minus mu divided by sigma. That part's okay, yeah? Okay, what I'm going to do is I'm going to plug in the values that I have. I know z is 1.28. I know mu, which is the mean, is 450. And I know my standard deviation is 80. Okay, and that's what I have here. 1.28 is x minus 450 divided by 80. Okay, and then so at this point, it's just algebra to solve for x. So I multiply both sides by 80, then I add 450 to both sides, and I get 450 plus 80 times 1.28 is x. So basically, once you get to here, all the hard work, or quote, the statistics part is done, and the rest is just algebra, okay? So, if you don't have algebra as, you might struggle in this part, okay? But, this class isn't algebra and statistics, so I'm assuming you guys can do this. Yes?
So why draw that out?
Yeah.
If we didn't need it?
Why did I draw this out?
Yeah.
Yeah, I guess we don't need it. You're right, we don't need it, but it also helps us to do kind of a little bit of a sanity check, right? Let's say I went through the work, but I made a mistake somewhere along the way. And instead of 552, I got 352, okay? Would 352 make sense for the 90th percentile of weights? No, it would not make sense because 352 would be down here, okay? And I think this picture tells us that whatever my answer is, if 90% of weights are below it, I know that number has to be bigger than 450, okay? And so drawing a picture a lot of times helps us kind of make sure that the answers that we have make sense, okay? Like if I'm getting a number less than 450, I know I've made a mistake, okay? Or if it's a multiple choice exam and I see any answer choices for less than 450, I know these ones definitely cannot be, okay? Even if I'm struggling with getting the actual answer because for whatever reason, like you forgot your calculator and you're like, what am I supposed to do? Well, you can start to eliminate some answers. You can say, well, if it's the 90th percentile, I can draw a picture. I know my number has to be over 450. And probably the answer choices, you can start throwing certain ones away and say, hey, now I'm down to a guessing game between two answer choices or something like that, okay? So, do we have to draw a picture? No. Is drawing a picture helpful? I think so, okay? All right, there is one more type of problem that shows up like this, and this is probably the trickiest of these, and I'm just gonna kind of show you how it works. So let's say you've got a question like this. So we'll still do turtle weights just so we can keep everything together. So we'll say turtle weights, normal model, mean of 450, standard deviation of 80. Okay? Somebody can ask a question. Let's go from 500 to 320. Okay? We'll say what percentage of turtles weigh between 320 grams and 500 grams. Okay? Well, to answer this question, we've got, I'm going to just duplicate this, okay? Okay. And I'm going to say the answer that we want is this area in green. What percentage of turtles weigh between 320 and 500 grams? Okay. The answer we want is in green, okay? Now, to get that, the table doesn't give this to us. So what we have to do is we're going to find the area in purple, and then we're going to subtract off the area in yellow. Okay? And can we see that? So our answer, the answer is equal to magenta minus the yellow chunk. Okay, can you guys see that? So if I take my magenta area and I subtract off the yellow chunk, I'll be left with the answer that I want. Okay, so we cannot get this answer directly from the table, but can we get this answer? Yeah, this is just what percent weighs less than 500. Can we get this answer? Yes, this is what percent weighs less than 320. Okay, so this will be, you know, this is what percent is less than 500. Okay, and this piece is what percent is less than 320. Okay, so once you have these answers or these pieces, then your answer will just be magenta minus yellow. Okay, or if we want to do some symbols, which some of you guys like and others of you don't, we would say x less than 500 minus probability that x less than 320. Okay, but it doesn't matter. Okay, but I hope this visual, this little diagram helps us understand how we would get answers to this. Okay, and so you have a practice question on the that's similar to this, and there'll probably be like one question like this on the midterm. Okay, and it's kind of like the challenge one to kind of distinguish my top performers from everyone else. Okay, so you know, this is, what's that? You know, it's a little bit tougher than the other questions. That's all. Okay. If you can't do this, it's okay. You can still pass even if you can't do this problem. All right. It's just you might see one. I don't think more than one. There might be a second, but I think there's only one. Okay. All right. So now we've got 20 minutes to cover the binomial model. Okay, so the binomial is this other chart. Okay, we've got this other chart. Now, the binomial distribution, once you figure out how to use this, it's very easy. The hardest part about the binomial distribution, which is your other table, is knowing that you have a binomial distribution problem, okay? Because on tests and, you know, and problems, it's not going to say, hey guys, this is a binomial problem, so make sure you look at your binomial table. It's not going to say that. You're going to have to read the problem and figure that out, okay? So, and I should also say, what we're learning in this class is like binomial light, okay? We're not going to, the actual binomial distribution is a little bit more complicated, but we're just going to learn how to get the answers from the table, and I think that's okay, all right? So this is what a binomial problem is, okay? So in a binomial problem, you are repeating a random experiment, a random trial, a certain number of times, okay? So you repeat a random trial n times. Okay, so I'm gonna draw a circle around n because that's going to be important. Okay, the random trials only have two outcomes. Only have two outcomes each time, which are arbitrarily labeled success and failure. Now, we associate success with good things and failure with bad things. But when we're talking about this, they're just arbitrary labels, okay? So it could be the random trial is a person is selected at random, and we want to know, and there's only two possible outcomes, and we're going to say, is this person male or is this person female? Okay? One of these we label success, and one of these we label failure, okay? But it's not to say that one is good or bad, it's just they're arbitrarily labeled as such, okay? So the random trials each only have two outcomes each time, okay? Arbitrarily labeled success and failure. Arbitrarily labeled success and failure. Okay, there's a question there? Oh yes, thank you. Thank you for reminding me, yes. Okay, so again, just like as before, number and write your name here, okay? So I'll start it here and then we'll just have it go around. Make sure you sign or write your name there before you leave today. Thank you for the reminder. Okay. So you repeat a random trial n times. The random trials only have two outcomes each time, okay? The probability of a success, quote unquote success, whatever we've called a success, is the same for each random trial. Okay, and that value is P. Okay, and we are interested in getting X successes. Okay? So every binomial problem is defined by n, p, and x. Okay, so all binomial problems have n, p, and x. Okay, so once you figure out, hey, this is a binomial problem, what you got to do is say, okay, what is my n, what is my p, what is my x? And all you do then is once you have those three values, you go to the table and you look up those numbers. Okay, so let's I'm going to just write out a few examples here. All right, so these are all examples of binomials, so you know you're looking for NP and X. Again, the hardest thing is this a binomial problem? Okay, this is kind of the checklist here. All right, so here's a binomial problem. I will flip a coin 6 times. With every flip, there is a 0.5 probability of getting heads. Okay? What is the probability I get heads 4 times? Okay. All right. So in our case, we got to find N, we need to find P, and we need to find X. So what is N? It's the number of times I'm repeating the trial. 6. Okay, I'm flipping the coin 6 times. What is P? It's the probability of a success. 0.5. Okay, every time I flip the coin, I've got a 0.5 probability. And what is X? I'm interested in getting 4 successes. So X is 4. Okay, so N is 6, P is 0.5, X is 4. Okay, so when we go to the table, we look it up in the order N, X, then P. Okay, so this is table lookup. For table lookup, you go in the order N, X, and P. Okay, so I've got N is 6, X is 4, and P is 0.5. So I'm going to go to the binomial table. So I'm going to scroll down to N equal to 6. So the very left-hand edge of the table is N. So I go to 6 right here. Okay, that's about halfway down the table. And then I go, the next column next to it is X. And it goes from 0 through 6. X goes from 0 through 6. I'm going to go to the row where it says X is 4. Okay? And then I look at the columns and I say, where is P equal to 0.5? Okay? So when P is equal to 0.5, I'm getting that intersection to be 0.234. Do you guys see that? Okay? And so what is the probability I get heads 4 times? My answer is 0.234. And that's it. Okay? Not too bad, eh? All right, let's, what's that? Yes.
Going to 6.
Yeah, we're going N equals 6.
Okay.
And then next to that, we have another column for X, and we go to,
Getting 1 and getting 2.
we get X goes to 4. So we go to the, N is 6, and then next to it, we have X equal to 4, and then we go to the column where P is 0.5. And that number is 0.234. Okay? All right, so let's, I'm going to give you a few example problems here and just kind of show you that to try to distinguish a regular old probability problem from a binomial problem. Okay? So I guess one key thing with binomial problems is that order does not matter for binomial. Okay, so let's try this. Okay, we play a game of chance 3 times. Okay, every time we play, we have a probability of win equal to 0.2. We have a 20% chance of winning, okay? So I'm going to ask A, what is the probability I win the first game and lose the last 2 games? Okay, and B is what is the probability I win one game out of 3, and C is what is the probability I win at least once. Okay. Let's see. Okay, I'll give you a few minutes to try to answer these questions. And then we'll go over these answers here. So if you're on YouTube, I'm going to pause right here. Okay, let's take a look here. What is the probability I win the first game and lose the last 2 games? So, okay, so in this case, order matters, so this is not a binomial problem, okay? So I've got to, the order of events has to be win, then loss, okay? So the probability of winning is 0.2. What is the probability of losing? 0.8, okay, simple enough. So this is going to be 0.2 times 0.8 times 0.8, okay? So I'm going to get 0.128 if I multiply these out. Okay, 0.2 times 0.8 times 0.8, 0.128, okay? In this case, it says, what is the probability I win 1 game out of 3, okay? So in this case, order does not matter, all right? And so this would be binomial, okay, where n is equal to what? How many times am I playing the game? 3. What's the probability I win each time? 0.2. And what's my x? I want 1. So I go to my table, and I go to n is 3, x is 1, and p is 0.2, and I get 0.384. Okay, so my answer here is equal to 0.384, okay? Now this is an aside and you don't have to write this. I'm going to write it in red so you don't have to write this down. This is the same, there are 3 ways to win 1 game out of 3. I can go win, loss, loss. I can go loss, win, loss, and loss, loss, win, okay? Each of these, this will have a probability of 0.128. This will also have a probability of 0.128, and this will also have a probability of 0.128, okay? So all of these 3 combined, if I add them together, is 0.384. So this is not a coincidence. This is basically, when you do the binomial probability table, it's doing this for you, okay? But the binomial probability table, it's nice that we don't have to do all of this and try to figure out every possible sequence of events. It just says, hey, this is the answer. Okay, what's the probability I win at least once? What am I going to do here? Yeah, 1 minus the probability of losing all. Okay, so this, there's 2 ways I can answer this, right? I can do 1 minus 0.8 raised to the 3rd, okay? Or I could say, hey, losing all, this is also the same as binomial problem, n equals 3, p is 0.2, and x is 0. Okay, because winning 0 would be the same as losing all. Okay, so I can look up npx 0, and then so losing all of this is 0.512. 0.8 raised to the 3rd is also 0.512. Okay, so there's 2 ways to solve this. So we get 1 minus 0.512 I get 0.488. .488.
So in that one, you probability and binomial.
You could do it either way and you'll get to the same answer. Okay?
Would you be able to solve B as a regular probability and get the same answer?
You can solve it as a regular probability, but it involves a lot more work in my opinion because it involves every possible arrangement of winning once out of 3 games. Now, in that case, there's only 3 possible arrangements. But if I said, what's the probability of winning 2 games out of 5? Okay, then you have a lot more sequences. Okay, something like 10 of them that you got to account for. So I think binomial makes more sense in those situations. Okay, good luck as you guys study. We'll see you guys next week. Please arrive on time. And yeah, so we'll see you.